We have ignition and we have liftoff. The initial calculation showed that we were going to be in great danger of getting really fuzzy pictures if we didn't do something to the spacecraft. It's that humility that science gives us. In the vastness of space exists a silent traveler, a relic of human exploration, NASA's Voyager 1. It has been venturing through space for over an amazing 45 years, still sending us valuable information from the distant parts of our solar system. But now something strange is happening. Voyager 1, now 24 billion kilometers from Earth, has begun sending mysterious data that has puzzled scientists. In this video we will embark on a journey of discovery to unravel the mystery behind what's seriously wrong with the Voyager 1 probe. Could we lose contact with Voyager 1, signaling its potential end? Could aliens eventually take over Voyager 1? Join us as we venture into space to investigate these strange signals and understand what's really happening to this remarkable spacecraft. To understand the gravity of Voyager 1's situation, we must first appreciate its incredible journey. The Voyager mission, launched in the summer of 1977, was expected to last 5 years. Yet, to everyone's astonishment, Voyager 1 and its companion Voyager 2 have defied these predictions, surpassing their expected lifespans. But not just that, for over 45 years, they've been continuously beaming back invaluable scientific insights from the farthest reaches of our solar neighborhood. Initially, these twin spacecraft were dispatched with the mission to explore Jupiter and Saturn, a task they fulfilled with great success. However, Voyager 2 didn't stop there. It embarked on a remarkable journey, making the very first up-close observations of Uranus in 1986 and Neptune in 1989 as part of what was aptly named the Voyager Grand Tour. Yet, their most remarkable feats were still ahead. In August 2012, Voyager 1 achieved an unprecedented milestone when it ventured into interstellar space, just 35 years into its mission. The world, however, only learned of this momentous event in 2013, when scientists had meticulously reviewed the data sent back by Voyager 1. In 2013, NASA officially declared that Voyager 1 had ventured beyond the Sun's influence into interstellar space, where it encountered a continuous stream of particles and magnetic fields unlike anything it had previously experienced. Voyager 2 joined its sibling in this cosmic frontier in 2018, a remarkable 17.07 billion kilometers away from the Sun. As we speak, Voyager 1 holds the title of the most distant human-made object from Earth, currently at a staggering 24 billion kilometers away. According to NASA's Jet Propulsion Laboratory, this unceasing traveler is moving away from us at an astounding pace, hurtling through the cosmos at 38,000 miles per hour, about 17 kilometers per second. These Voyager missions are unparalleled in their contributions. They've offered us exclusive insights into our solar system and its surroundings. The probes have been busy studying how the interstellar medium interacts with the solar wind. A stream of charged particles perpetually emitted by the Sun. Voyager data has also shed light on the heliosphere, a bubble of charged particles enveloping our solar system, sculpted and influenced by the interstellar environment. According to NASA, scientists have combined Voyager observations with data from newer missions to get a more complete picture of our Sun and how the heliosphere interacts with interstellar space. Ultimately, Voyager 1's enduring mission has broadened our horizons and ignited our collective imagination, etching a timeless legacy in the annals of space exploration. Meanwhile, scientists estimate that our first contact with extraterrestrials could be in 2029. They believe that if there were extraterrestrials, the messages sent to them using Voyager 1 would have reached them as early as 2002. While this will be a paradigm shift in the history of humanity, many people are eager to know what could happen if Voyager 1 meets extraterrestrial life. We'll get into this in a bit, but first, how has Voyager 1 persisted for an astonishing 46 years and counting? When we talk about Voyager 1's incredible endurance, its toughness stands out. Imagine a machine navigating through the harshest place you can think of, space. In space, you've got wild radiation, extreme temperatures that can freeze or fry, and even tiny space rocks zipping around. Most things wouldn't stand a chance out there, yet Voyager 1 has been trucking along for a remarkable 46 years and 5 days, counting from September 12, 2023. A big reason behind this staying power is that it was built well. A salute to the brilliant engineers and officials who crafted this spacecraft. They ensured it could handle a pounding from cosmic radiation, extreme hot and cold swings, and those pesky little space rocks. The probe has also survived for so long due to its power source. You know solar panels, right? Those flat things on some rooftops that soak up sunlight to make electricity? Well, Voyager 1 couldn't rely on those because it ventured far from the cozy embrace of the Sun. Instead, it uses something more exotic, nuclear batteries, also known as radioisotope thermoelectric generators (RTGs). These aren't your typical batteries. They convert heat from the natural decay of plutonium into electricity. These RTGs have been Voyager 1's power system's reliable heart, keeping it strong for more than 4 decades. Over time, their power output has dipped due to radioactive decay, but they still provide enough juice to keep all the scientific instruments on board humming. Voyager 1 isn't just an ordinary spacecraft, it's also a brainy explorer. It's packed with instruments like a scientific Swiss Army knife, cosmic ray subsystem (CRS), high-gain antenna, imaging science subsystem (ISS), infrared interferometer spectrometer and radiometer (IRIS), low-energy charged particles (LECP), magnetometer (MAG), optical calibration target photopolarimeter subsystem (PPS), planetary radio astronomy (PRA), plasma science (PLS), plasma wave subsystem (PWS), radioisotope thermoelectric generators (RTGs), and ultraviolet spectrometer (UVS). These instruments aren't just fancy decorations, they've done some serious work. Voyager 1 has used them to unravel mysteries about giant planets and their moons. Close-up snaps from the spacecraft have given us the lowdown on Jupiter's swirling cloud patterns, wild winds and storms. It even spotted volcanoes on Jupiter's moon Io. Over at Saturn, the rings were more than just pretty jewelry, they had peculiar twists, turns and spokes, and they come with a whole lot of ringlets. But it's not just about pretty pictures. These instruments have also been cosmic detectives. They've dabbled in cosmic rays, studied charged particles, poked at magnetic fields and eavesdropped on plasma waves. Meanwhile, as Voyager 1 hurtles through the cosmic void, it carries a remarkable treasure, a message from Earth destined for the unknown. This unique record, known as the Golden Record, is humanity's attempt to communicate with any extraterrestrial being that it might encounter on its endless journey. The Golden Record is a remarkable artifact, a 12-inch gold-plated copper disc holding a trove of sounds and images carefully chosen to depict Earth's diversity of life and culture. It is a window into our world, a story of our species and planet, and an attempt to bridge the gap between civilizations separated by the vast expanse of space. Within the confines of this small shimmering disk are 116 images and a symphony of sounds. Among them are the harmonious melodies of our music, spoken greetings in 55 languages from different corners of our globe, and the raw, unfiltered sounds of nature, thunderclaps, the songs of birds and the haunting calls of whales. Each element was handpicked by a committee led by the renowned astrophysicist Carl Sagan, representing a tapestry of our world's cultures and experiences. The Golden Record is entrusted to Voyager 1 and its twin craft Voyager 2. It's fascinating to think that these Voyagers carry a message from Earth that could be discovered by extraterrestrial life in the distant future. If, by some incredible chance, an advanced extraterrestrial civilization were to come across Voyager 1 and retrieve the Golden Record, it would be a momentous event in the history of interstellar communication. Here are 3 possibilities of what might happen. The extraterrestrial civilization would likely attempt to decipher the contents of the Golden Record. With their advanced technology, they could understand the visual and auditory information encoded on the disk. Secondly, if extraterrestrial beings were capable of interstellar travel or communication, scientists predict that they might subsequently return a signal expected to reach Earth by 2029. Alternatively, they might choose not to interfere with Voyager 1 and simply study it as a historical artifact. They might want to respect the principle of non-interference in other civilizations' development, a concept explored in many science fiction stories. In any case, if there were ever an encounter with extraterrestrial beings, it would be a massive and potentially world-changing event for humanity. However, Voyager 1, despite its long and faithful service, has recently introduced an element of intrigue into its mission. It has begun transmitting perplexing data from the fringes of interstellar space, sending NASA engineers into a state of bewilderment. This anomaly emanates from a crucial onboard system known as the Attitude Articulation and Control System, AACS. This system is responsible for measuring, reporting, and adjusting the spacecraft's position in the unforgiving expanse of space, ensuring that its antenna stays pointed toward Earth for communication and data transmission. Yet, inexplicably, the AACS returns data that contradicts the spacecraft's actual movements and orientation. It's as if Voyager 1 has become disoriented, uncertain of its location. In the cosmic void, NASA's assessment of the situation is reassuring yet perplexing. According to NASA, despite the erroneous data from the AACS, Voyager 1 continues to function normally. It dutifully receives commands from Mission Control on Earth and diligently collects valuable scientific data from its distant vantage point. The spacecraft seems undisturbed by the anomaly, and no onboard fall protection systems have been triggered, those safeguards that would put the craft into a protective safe mode. Intriguingly, Voyager 1's communication signal remains strong, a steadfast beacon in the void. The high-gain antenna is unwavering, pointing in the right direction toward its home planet. But the mystery deepens. The telemetry data returned by the AACS appears to be generated at random or, at times, defies any logical interpretation. Suzanne Dodd, the project manager for both Voyager 1 and Voyager 2, sheds light on this confounding situation. She reminds us that such mysteries are not entirely unexpected in the twilight of the Voyager mission. These spacecraft, now aged beyond their intended lifespan, have journeyed farther and longer than anyone dared to dream. Moreover, they traverse interstellar space, a harsh, high-radiation environment and uncharted territory where no spacecraft has ventured. While the engineering team is facing a tough challenge, they remain optimistic about finding a solution for Voyager 1's problem with the AACS. If they pinpoint the source of the issue, they might be able to fix it with changes to the spaceship software or by using backup hardware systems. It's worth noting that Voyager 1 has encountered a similar hurdle before. Back in 2017, the primary thrusters started showing signs of wear and tear. The engineers had to switch to thrusters that hadn't been used for 37 years during the spacecraft's planetary missions to keep the mission going. But now there's a new twist in the tale. NASA's clever engineers have identified the problem with Voyager 1. It turns out that the AACS was sending telemetry data to a computer that had failed a long time ago, and this corrupted the data. The project manager suspected this was the culprit and took a calculated risk by repeatedly commanding the AACS to send data to the correct computer. While the engineers are still uncertain about why the AACS veered off course, a malfunctioning command from another onboard computer likely triggered this anomaly. If that's the case, it suggests that an underlying problem on the spacecraft may exist elsewhere. The team remains committed to uncovering the root cause, although they believe it doesn't significantly threaten Voyager's overall health. Nonetheless, they are eager to understand Voyager 1's inner workings better. However, it's important to recognize that Voyager 1's journey through space will eventually end. In fact, time is running out for this intrepid explorer. This leads us to a pressing question. How long can NASA's Voyager continue its incredible journey through the cosmos? This question is a fascinating one with multiple aspects to consider. But before we delve into this, it's essential to understand how Voyager 1 manages to communicate with us from an astounding distance of 24 billion kilometers and the factors determining how far it can go before we lose contact altogether. Voyager 1's ability to stay in touch with us hinges on a well-thought-out radio communication system that is meticulously designed to work efficiently within and beyond our solar system's boundaries. At the heart of this system is a sizable 3.7-meter diameter high-gain Cassegrain antenna. This mighty antenna plays a crucial role in transmitting and receiving radio waves, and it does so through the 3 Earth-based stations that make up the Deep Space Network. When Voyager 1 communicates with Earth, it usually does so via Deep Space Network Channel 18, utilizing radio frequencies of either 2.3 GHz or 8.4 GHz. Conversely, when we send signals to Voyager, we do so at a frequency of 2.1 GHz. This sophisticated communication setup allows Voyager 1 to maintain a connection with our home planet, even as it journeys into the vast unknown. However, the distance Voyager 1 has traveled means that direct communication with Earth has become increasingly challenging. To overcome this, the spacecraft is equipped with a digital tape recorder, DTR, capable of storing roughly 67 megabytes of data. This recorded data can then be sent back to Earth later when conditions for communication are more favorable. As of 2023, it takes over 22 hours for signals from Voyager 1 to reach Earth, a stark contrast to the roughly 15 minutes it takes for the Mars rovers to transmit data back to us. Another essential factor to consider is the weakening of Voyager 1's signal as it traverses the vast cosmic distances. The spacecraft initiates data transmission to Earth using a 20-watt signal. However, over its long journey through space, this signal progressively weakens. By the time it reaches Earth, it has become exceedingly faint. Nevertheless, the strength of the signal isn't the primary concern when communicating with objects at such colossal distances. The critical factor is having a sensitive receiver capable of detecting these faint signals. To meet this challenge, NASA relies on the Deep Space Network, a network of 3 antenna complexes strategically positioned around the Earth. Each complex boasts a substantial 70-meter antenna and multiple 34-meter antennas. These facilities can combine their capabilities to detect signals that are thousands of times weaker than a standard FM radio signal. The Deep Space Network allocates several hours each day to monitor these faint signals from Voyager 1, and it has consistently demonstrated its responsiveness over the past 5 decades. Our methods for detecting these signals have seen significant advancements. Consequently, there is no practical limit to how far we can extend our reach in communicating with distant space explorers. Current technology empowers us to communicate with objects situated light years away reliably, provided we possess sensitive and precise receivers to capture these exceedingly weak signals. So how far can Voyager 1 truly journey into the depths of space? The answer lies in the ever-expanding gulf that separates it from our home planet. With every passing day, Voyager 1 inches farther away, a celestial messenger on an endless odyssey. However, sending and receiving signals becomes increasingly challenging as Voyager 1 ventures farther from Earth. The data rates slow down, making it progressively more difficult for us to communicate with this intrepid traveler. Despite these challenges, Voyager 1's journey knows no bounds, and theoretically, there is no set limit to how far we can extend our communication. Yet in practical terms, we face a harsh reality. Our ability to communicate with this remarkable spacecraft has an expiration date, and this date is just a few years away. Voyager 1's finite energy reserves limit its capacity to collect scientific data. One of its key instruments, the cosmic ray subsystem, is on a mission to measure particles that emanate from celestial objects like stars, providing us with invaluable insights into the universe. However, Voyager 1 is powered by a nuclear source, hence it experiences a gradual decline in electrical power with each passing day. In 1990, engineers took a significant step to conserve power by switching off Voyager 1's camera after it captured the iconic pale blue dot image, depicting Earth as a minuscule speck against the backdrop of space's profound darkness. Of the 11 scientific instruments on board, only 5 remain active today. Engineers have had to make tough choices to keep these instruments operational, such as disabling heaters and other components. These active instruments continue to serve as our eyes and ears in the depths of space, gathering essential data about magnetic fields, solar winds, and cosmic rays outside our solar system. Fast forward to 2022, NASA implemented energy-saving measures to extend the mission's duration beyond 2025. But as of 2023, the space agency announced additional power-saving efforts that will delay shutting down one of its science instruments until 2026, instead of this year. However, despite these efforts, it's reasonable to anticipate that more of these instruments will begin to go offline by 2025 or 2026, although some might persist until the end of the decade. The inevitable end of this epic voyage looms on the horizon. In the mid-2030s, we will likely receive our final message from Voyager 1.